Good day everyone. Our topic for today is series and parallel circuit. Understanding these two types of circuits is essential in the field of electrical work as they are the foundation of how electricity flows and powers devices. By the end of this discussion, you will be able to define the series and parallel circuit, appreciate the importance of knowing the series and parallel circuit, and compute series and parallel circuit using Ohm's law and Watt's law.
What is an electrical circuit? An electrical circuit is a closed loop allowing electricity to flow. Basic components include a power source, battery, conductors, wires, and a load light bulb. A switch can open or close the circuit to control the flow of electricity. An electrical circuit is a closed path through which electric current flows. It typically consists of a power source like a battery, conductors such as wires, and components like resistors, switches, or light bulbs. So, we have different types of circuits: the series, parallel, and combination circuit. What is a series circuit? In a series circuit, all components are connected end-to-end in a single path. Series circuit components that are connected one after another. The same current flows through all parts. What is a parallel circuit? In a parallel circuit, components are connected across common points, creating multiple paths for electricity to flow. The parallel circuit, components that are connected across common points, allowing multiple paths for the current. So, the last types of circuits is the combination circuit. Combination circuit is the mix of series and parallel connections.
Series versus parallel circuit. So always remember, in a series circuit, all components are connected along a single path, meaning the same current flows through each part. On the other hand, a parallel circuit has multiple paths allowing current to divide and flow through different branches. So what makes an electric circuit complete? A simple circuit consists of a battery or other source, a light bulb or other load, and conducting wires. Shown below are other circuit components and their corresponding electrical symbols. So we have battery, closed switch, open switch, resistor, motor, and fuse.
The total resistance in a series circuit is computed by adding all resistance. The formula in computing the total voltage in a series circuit: total voltage equal E1 plus E2 plus E3. The formula in computing the total current in a series circuit is total current equals I1 equals I2 equals I3. The total current in series circuit is equal to the flow of current in each loads. So, in series circuit, we have R1, 100 ohms, R2, 200 ohms, R3, 300 ohms, and 12 voltage. In getting the total resistance, the formula total resistance R1 plus R2 plus R3. So, in R1, we have 100 ohms, R2, 200 ohms, R3, 300 ohms. The total resistance is equal to 600 ohms.
So next, we are going to compute for the total current. So in getting the total current, the formula is the total current equals the total voltage divided by the total resistance.
Total voltage divided by total resistance of 600 ohms. Total current is equal to 0.02 amperes. So we have 12 volts, see R1, 100 ohms, R2 200 ohms, R3 300 ohms, and the total current is 0.02 amperes.
So, in series circuit, the current flows through it is equal.
Again, the total resistance is 600 ohms. So next, we are going to compute the voltages. Total voltage is equal to current times resistance 1. Current number 1 is 0.02 amperes times 100 ohms. Total voltage is equal to 2 voltage. Voltage 1 is equal to 2 volts. E2 equals I2 times R2 resistance 2, 0.02 amperes times 200 ohms. E2 is equal to 4 volts. E3 equal I3 plus resistance 3, 0.02 amperes times 300 ohms equal to 6 volts. Then, ikakopy na lang natin ta sa taas. Voltage 1, 2 volts. Voltage 2, 4 volts. Voltage 3, 6 volts.
So, pag inad natin lahat yung voltages, magka-come up tayo dun sa total voltage which is the 12 volts.
The total voltage in parallel circuit is always equal to the voltage across each load. The formula in getting total voltage is total voltage equals E1 equal E2 equals E3. The formula in getting the total resistance in parallel circuit, total resistance equals 1 over 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. The formula in computing the total current in a parallel circuit is total current equals I1 plus I2 plus I3. Let's get the total resistance first. The formula is 1 over total resistance 1 over R1 plus 1 divided by R2 plus 1 divided by R3. One over 1 divided by R1, 5 ohms, plus 1 divided by resistance 2, 10 ohms, plus 1 divided by R3, 20 ohms, equals 1 over 1 divided by 5, 0.2 plus 1 divided by 10, 0.1 plus 1 divided by 20, 0.05. 1 over, i-add na natin yung 0.2 plus 0.1 plus 0.05 is equal to 0.35. Total resistance is equal to 2.86 ohms.
So, before we compute for the total current, let's compute first the current in each load.
I1 is equal to E1 divided by R1 equals E1 50 volts divided by 5 ohms. I1 is equal to 10 amperes. I2 equals E2 divided by R2. E2 is 20 volts and R2 10 ohms. I2 50 volts divided by 10 ohms is equal to 5 amperes. The last one is I3 is equal to E3 divided by R3 equals 50 volts divided by 20 ohms. I3 is equal to 50 volts divided by 20 volts is equal to 2.5 amperes.
To get the total current, let's add them all.
Current I1 plus I2 plus I3. I1 is equal to 10 amperes plus I2 5A plus I3 2.5 amperes. The total of 17.5 amperes. Total power P1 is equal to I times E. I1 is equal to 10 amps times 50 voltage equals 500 watts. P2 is equal to I times E. 5 amps times 50 volts is equal to 250 watts. P3 is equal to I times E equals 2.5 amps times 50 volts is equal to 125 watts. To compute the total power, let's add them all na lang yung power. P1 equal to 500 watts plus P2 equal to 250 watts plus P3 equal to 125 watts. Total power is equal to 875 watts. The total resistance is 2.86 ohms and our voltage as is 50 volts. Current 1 10 amps, current 2 5 amps, current 3 2.5 amps. So then i-add natin 17.5 amps. The total power 875 watts.
In computing series to parallel circuit, first get the total resistance of loads connected in series or the R1 and R2. So the formula in getting the total resistance of loads connected in series is RA is equals to R1 plus R2. Now that the load connected in series has one value or the RA, get the total resistance by parallel with the remaining value of resistance. So the formula in getting the total resistance is equals to 1 divided by 1 over RA plus 1 divided by R3. For example, we have resistance 1 which is 12 ohms, resistance 2 which is 14 ohms, and resistance 3 which is 2 ohms. So to find the total resistance, let's get the total resistance of loads connected in series first. So the formula in getting the total resistance of loads connected in series is RA is equals to R1 plus R2. So ang R1 natin is 12 ohms plus R2 which is 14 ohms. Add lang natin. So our RA is 26 ohms. So the formula in getting the total resistance is equals to 1 divided by 1 over RA plus 1 over R3. So copy lang ulit natin yung 1 and then 1 over RA which is the 26 ohms plus 1 over R3 which is the 2 ohms. Copy ulit yung 1 and then i-divide na natin yung dalawa. 1 divided by 26 is 0.03 plus 1 divided by 2 is 0.5. Add lang natin ulit. So 0.03 plus 0.5 is equals to 0.53. So, di-divide na natin. 1 divided by 0.53 is equals to 1.87 ohms. Therefore, the total resistance is 1.87 ohms. In computing parallel to series circuit, first, get the total resistance of loads connected in parallel circuit, which is the R1 and R2. So the formula in getting the total resistance of loads connected in parallel is RA is equals to R1 times R2 over R1 plus R2. Now that the loads connected in parallel have one value, which is the RA, get the total resistance by series with the remaining values of resistance. So the formula in getting the total resistance in parallel is total resistance is equals to RA plus R3 plus R4. Say for example, in a parallel to series circuit, we have R1 which is the 3 ohms, R2 which is the 5 ohms, R3 which is the 7 ohms, and R4 which is the 2 ohms. We also have I1 which is the 2 amperes, I2 is 8 amperes, I3 which is 5 amperes, and I4 which is 3 amperes with a voltage of 50 volts. So the formula in getting the total resistance of loads connected in parallel is RA is equals to R1 times R2 over R1 plus R2. So RA is equals to R1 which is the 3 ohms times R2 which is the 5 ohms over 3 ohms plus 5 ohms. So 3 times 5 is equals to 15 ohms over 3 plus 5 is equals to 8 ohms with a total of 1.88 ohms. So our RA is equals to 1.88 ohms. So the formula in getting the total resistance is total resistance is equals to RA plus R3 plus R4. So RA which is 1.88 ohms plus R3 which is the 7 ohms plus R4 which is the 2 ohms. Now let's add them all. .88 ohms plus 7 ohms plus 2 ohms is equals to 10.88 ohms. Therefore, our total resistance is 10.88 ohms. Now, let's find the total current. So, in computing the total current, the formula is total current equals I1 plus I2 plus I3 plus I4. I1 is equals to 2 amperes plus I2 which is the 8 amperes plus I3 which is the 5 amperes and I4 which is the 3 amperes. Now let's add them all. 2 amperes plus 8 amperes plus 5 amperes plus 3 amperes is equals to 18 amperes. Therefore, the total current is 18 amperes. The formula in getting the total power is total power equals total current times total voltage. So, total current multiplied by voltage, which is 18 amperes times 50 volts, is equals to 900 watts. Therefore, the total power is 900 watts. And our total voltage is 50 volts.
Again, electric circuit, it is a complete path through which electric current flows. Series circuit, a series circuit is an electrical configuration in which all components are connected end-to-end in a single continuous path. Parallel circuit is a electrical circuit that has a number of different paths for current to flow through.